All right. Another parameter that you need to know is the concrete modulus of rupture. Okay. Okay, concrete modulus of rupture ni awak boleh buat, you're using also is a lab test according to ASTM C78. Okay, is a mean value. Okay, mean value that been determined after 28 days. 28 days using the third point loading. Okay, this is the testing that you need to conduct first in order to determine the modulus of rupture of the concrete. Okay, so this some sort of like the correlations have been developed by previous researchers, okay, studies before, okay, between concrete modulus, modulus of rupture, and also the compressive strength test. Okay. Then apart from that, okay, another variables that you need to do is load transfer coefficient. As I mentioned, okay, the load transfer coefficient depending on the transverse joint, right? Depending on the dowel, right? So the J value. So you have to refer to this table where it depends on one thing is the shoulder. Okay, the shoulder of the pavement, whether you're using an asphalt shoulder or using a concrete shoulder, right? So if it's if you're using asphalt shoulder, okay, if there is a load transfer device, okay, so this would be the J value, the load transfer coefficient, depending on what type of concrete pavement you want to design. Okay, if it's a concrete shoulder and also the load transfer device, yes, this one. Okay, for the concrete pavement. All right, so that would be one parameter that you need to know, and this one is the same. Okay, similar to what we discussed in flexible pavement, but this specifically for concrete pavement. Okay, this for concrete pavement. The same thing, you need to know the drainage coefficient. Reliability also the same. Okay, you need to know the probability that your design is not following. There might be some failure. Okay, what will be the probability happen? Okay, so okay, this is the recommended reliability. Okay, the higher types of the pavement, the higher the higher the traffic volume, the higher reliability that you need to design. Okay, variability when it comes to standard deviation, how accurate the data that you input into your design. Okay, so you need to have your standard deviation for your design. And that ISO will be the same. Okay, the calculation for the ISO will just be will be the same as flexible pavement. Okay, serviceability also the same. Okay, you need to know the initial serviceability. Okay, because we wanted to determine the loss in serviceability. So we have to the initial serviceability, initial minus the terminal. Okay, and you will get the loss in serviceability that you want to cater with. Right, so once you have all the parameter with you, so as I mentioned, we need to have what? We need to have K, we need to have the EC, SC, the J value, right? What else? The drainage coefficient, reliability, standard deviation, loss in serviceability. Okay, once you have all those parameters, you can just straight away go to the normal graph. I hope you print the normal graph with you. Right, so this is the normal graph. This is the first part of the normal graph. Okay, and this will be the second part of the normal graph. Okay, dia bersambung. Okay, it continues. Starts from here to here. Then you reach this match line, and then you continue to the next paragraph where it starts from the match line here. Start from here, and it will meet the final stage at this point. Okay, so we're gonna look on one example. One example. How do you actually use this normal graph from this example? Okay. Right, so it's given here, all right, a pavement for 2-lane urban principal arterial, okay, 20 years, okay. During the first year, two-way equivalent single axle applications are 167. So it's an ESL, okay, equivalent single axle. All right, 167, two-way, two-way. Is a 2-lane, okay, 2-lane. Traffic growth rate 3%, reliability 90%, and the overall standard deviation is 0.35. And initial serviceability was recorded to be at 4.5, and terminal serviceability is 2.5. Okay, then What else did the question give you? Okay, given here the concrete pavement is to be laid on a granular subbase. Okay, using the standard laboratory test on 28 days, the compressive strength is 5,000 psi. So this is the FC, the average compressive strength. And the average modulus of rupture, okay, 600,000. So this is the modulus of rupture, SC. All right. The drainage was judged to be good and will be subject to moisture level approaching saturation 3%. The pavement is being designed with a JRCP with untied asphalt shoulder, right? And the effective modulus of subgrid reaction corrected for loss of support, right, is 1 to 8. Okay, this is the K, right? The K. Determine the thickness of the concrete slab. Right. So how are you going to do that? Right. So first of all, you have to what? You have to list down all the information. What are things that been given inside this question? Okay. Let's do it together. Okay. I hope that you have your. Oh, what is this? Pergi ke sini pula buat apa? Mana aku punya ni whiteboard? Okay, so sekarang please list out all the informations given in the question. Clear canvas. Oh, so small, man. Why is it so small? Is it the question? Oh, is it so too small, man? Awak lah jadi kecil macam ni. Tak boleh besar lagi ke? Kecilnya, tak nampak I. Macam nak besarkan? Tak boleh zoom. Boleh itu ke? Tak boleh lah. It's too small. Okay. Delete. Never mind. Okay. Let's list out the details. Okay. Can you please tell me, anybody, what things, what are the variables that you can take it up from this the given question, from the given question? Just shout out. What? Cell?
Easel.
Easel. Oh, easel. So it's given easel. Apa ni? Easel. Easel? Come on, what?
167000.
16700.
One more zero.
One more zero. Okay. 167000. So this Excel for what? For one per lane per
year.
What? Huh?
For two-way, two-lane.
For two-way, right?
Two-way.
Two-way and
two-lane.
Two-lane. All right. Two-way and two-lane. Right. What else? This for ISO for year 1, Year 1. Macam ni lah nak tulisan cantik. Okay, right. What else?
Growth rate.
Growth rate. Okay, growth rate berapa?
3%.
3%. Okay. Now, what can we do with this information? Can you find the ESL design? Okay, because this is ESL for year 1, right? So we need to calculate the ESL design. Okay. Macam mana buat kira ESL design? Right, never mind. Apart from calculating the ESL, okay, let's list out what are things that you have. What are the things that, okay, tak apalah, we calculate the ESL design first. Right, calculate the ESL design. So what do we need to multiply? Who wants? Okay, the growth factor. You need to determine the growth factor. All right. The growth factor. So growth factor, you want to look on the table or you want to calculate? You can look at the table as well, right? The table where you have the apa namanya, Allahu Akbar. The N is 20 years, right? N is 20 years. What will be the growth factor if R 3% and N 20 years? Hello? Hello? Hello?
Sekejap doktor tengah tengok.
Oh, tengah cari. Okay, okay.
Sekejap.
You could calculate either using the formula or you could refer to the table. There are two ways to determine the growth factor. Lama benar. Tak jumpa ke tablenya?
Jumpa doktor.
Aha. Lama benar.
27. Kira.
Oh, kira okay.
27.04. Buat interpolation.
27.04. 27.04.
Betul.
04.
04.
Is it correct? The rest, if you refer to the table, is it the same?
In the table, there is no 3%, only 2.
Oh, the table doesn't have 3%. Okay, now then go for if try using the formula. Okay, do you still remember the formula? The formula, try tengok formula. Tak ada table, tak ada, kita guna formula. Formula berapa? 1 campur
1 plus G
1 plus G
power of N
divided by
minus 1 divided by G.
minus 1 divided by G, like this. Is it correct?
Yes.
Okay, try.
Doctor, 4.4 million?
24.4 million.
No, 4.4.
4.4 million. What is it? Is it the diesel design?
Yeah.
Okay, what is your growth factor, Zaid?
26.8.
26.8. Okay, 26.8. Siapa ada call? Wait, 1 minute. I have a call. Hello, Kak Edi tengah kelas. Kenapa dah ya? Tengah ada kelas. Nanti tengah ada kelas. Okay. No problem. Okay. Right, so the rest, you're using the formulas, Zaid? 26.8, you're using the formula, right?
Yes, doctor.
Alright, so kita dapat, supposed to get 26.8, if you're using the formula. So what you have here is 167,000 times the growth factor 26.8. Alright, so what else? What else do you need to do?
Distribution and
Yes.
Directional and lane.
Yes, you need to multiply with directional distribution and lane distribution. So we know that it is for two-way and two-lane, right? Two-way, this value is for both directions with two lane. Okay, so we need to multiply with the directional distribution. So we assume in directional distribution, we normally have 0.5. 50%, 50%, the same percentage. How about the lane distribution? Okay, the lane distribution, you could refer to the same the same table as in the flexible pavement. This is rigid pavement slide. You could refer back to your flexible pavement. There's a table, right? Suggesting the do we have this on my slide? Should have it. Design mix. Oh, saya dah buang. Saya dah kena buka balik. Alright, right. I go back to my
80-100 doktor.
80-100 Okay, 80-100. Right. The range, if you look on the table given, the range would be if is it 2 lane per direction, if is it between 80 to 100%, right? The range for 2 lane. So we take the minimum one. Okay, let's take the minimum one. We just take 80 lah. Let's say just take 80%. So the lane distribution we multiply with 0.8. Okay, right? So what do we have? What do you get for the ESL design?
1.79 million.
1.79 million. Okay, million. All right. So the ESL design is 1.8 or 1.79 lah. Okay, we multiply with 1.8 million. Alright. So done with the Isat. So what else that we can get from the question, guys?
Reliability.
Reliability. Okay, reliability. What will be the reliability? So again, okay, you need to pick from the table, right? The table, from the table given the range. Sorry, I go
Oh,
down.
in the question already stated 90%.
Dia
Oh,
dah bagi doktor.
it's restated. Okay, okay. What will be the reliability? 90%.
Yes.
90%. If it's not been given, so you need to refer to the table, eh? Okay, what else? Reliability.
Standard deviation.
Standard deviation.
Standard deviation.
So standard
0.35.
0.35. Okay, what else?
Servability is 4.5.
Huh?
2.
What? Loss in serviceability.
Yes, delta B
Okay.
is 5.
Loss
Two.
in serviceability. So we have loss in serviceability
2.
2.
2 because where you come through, we have 4.5 and 4.5 minus
2.5.
2.5. Okay, so therefore we have 2. Okay. Oh Allah, tu padamlah pula. PS. Oh, but. Okay. 4.5 minus 2.5, we have 2. Okay. Okay, what else do we have for the variable? FC. Right, so FC is given. FC is
5,000.
5,000.
5,000.
5,000. All right, so we need to calculate the EC, right? The EC equal to 5700. What was the formula?
57000.
57000 times FC. Is it true?
Square root.
Square root?
Yes.
Square root
Square root
berapa?
FC.
Square root FC. Square root FC. Dah lah, sekejap saya tengok slide dah. Saya pun tak hafal formula, wait. Okay. Right. So 5,000 square root FC. Right. So 5,000 punca kuasa FC. Right. Square root. Okay. Right. So what the value is? So FC here is 5,000. Is it from the question? The compressive strength test is the FC
Yes.
5,000. So what's the value for the concrete modulus?
5.3 million.
5.3 million. Is it? Okay. The rest get the same value?
5.
5.3 million. Betul ke million? Okay. Betul ke? I'm going to fast forward.
Got 4 million.
4.4 million.
Dapat 4 million. Okay.
4.03 million.
4.3. Okay, the rest dapat berapa? 4.3 ke 5.3?
4 million.
4 million. Okay.
Yeah, 4.03.
Okay, we take it as 4. Right, so calculate back your answer. Maybe you got wrong, Zahid. 4 million 4 million Kita ambil 4 million 4.03 yang tadi. Right, okay. What else? How about the drainage coefficient?
Good drainage. 3% time to push.
CD. Right, the drainage coefficient. So drainage coefficient, it is if you look here, the questions given, the drainage coefficient is good and 3%.
3%, yes.
Okay, good and 3%. So look back on the drainage and good and 3%. Okay, somewhere in the middle of here, 1.5 and 1.1. So what will be in the middle here? It's roughly in the middle, right? So I would say 1.1. 1 berapa? 1? 3? Or you're doing interpolation?
1.13.
Okay, so we'll take CD 1.13 because it's at the middle, right? 3%. Okay, then okay, good. What else? Apa lagi? CD, the J value, the load transfer coefficient, right? You haven't know the load transfer coefficient, J value. So J value will refer to the this figure, J value, right? So what's in the question? The question say you're using hot mix, they're using asphalt shoulder, right? Asphalt shoulder, and what type of pavement is that? It is a JRCP, right? It's a jointed reinforced concrete, apa nama? Jointed reinforced concrete pavement. Dia ni tak apa? Soalan dia ni tak does it have dia tight ke tak tight, load transfer device ke apa dalam soalan tu?
Untight asphalt
Dia
shoulders.
cakap with untight asphalt shoulder. Alright, so we assume that it is no load transfer device. Where's the here? So this one. Alright. So therefore it will be between 3.8 to 4.4. Alright. So anything we can just get any value. So we just take a 4 lah. We just take 4 as long as within the range. Okay. So we take 4. So J value is 4. Okay. Alright. So done. What else do we missing?
SC.
Huh? SC. Oh
Yes.
yes, the SC is given. The modulus
600 PSI.
600 PSI. Okay.
Yes.
PSI. Okay. Right. So you have all the information gathered here, right? So all this number 1. Okay, number 1, number 2, number 3. Okay, berapa? 4, 5, 6, 7, 8. Okay. Apart from that, apa lagi? Rasa tu je kot. We'll check back again. Okay. We'll check back again if you have missing anything. Okay. Then once we have all the information ready, we can just go to the normal graph. Okay. Have you print the normal graph? So we'll take the first normal graph. Okay. The first normal graph. Okay, right. So the first normal graph, it's here, it says here, start from here. Start from the modulus of subdeviation. Yes, our modulus of subdeviation, the K value. What is the K value? It's not given. We are not listing on the, you don't list it out. Okay, berapa K value? It's given to you, right? The K value from the question is? What is the K value?
128.
1, 2,
8.
8. 1 to 8 PCI, right? So we
Yes.
start drawing a line from 1 to 8. So where's 1 to 8 in the normal graph? Okay, you need to draw a line, vertical line from the K value towards the modulus, concrete modulus. Your concrete modulus, this is the line for concrete modulus. Okay, this is the line for concrete modulus from 3, 4, 5, 6, 7 million. So our concrete modulus is where is the modulus? EC 4, right? We have 4. The concrete modulus is 4 million. Okay, so 1 to 8. So where's 1 to 8? 100, this is 200, this is 3, 400, 500. So 1 to 8, this is 1, 2, 3, 4, 5. So 1 to 8 something to in the middle here. Right? So please do on your paper, don't just look on my slide. Okay, I want you to have some sort of like hands-on. Normally kat dalam class, if you have face-to-face class, I ask them to draw on the paper that they had in front of them. 100, so 120, somewhere here. Okay. So you draw a line. Okay. What line something 1 to 8. Correct, Boleh? Betul semua dapat? Right, then we go where it stopped to the 4th. 4 million of concrete modulus here. Can you see here? 4 million. 3, 3, 4, 5, 6, 7. So we go to the 4. 4 million concrete modulus. So the next checkpoint is you have to draw horizontally 90 degree, horizontally pergi ke hujung sini. Okay, you draw on your paper. I'll do on mine. Saya macam ingat lah sikit line saya, tak apalah. Alright, okay. Then the next checkpoint is what? The next is modulus of rupture, right? Modulus of rupture, SC. So what is our SC? Our SC is 600. 600, alright? SC 600. Okay, so this is 600. From the way you stop here, you draw a line straight to the 600 and extend the line straight to the turning line here. Okay, so sini, okay. Right. Lebih kurang lah, saya punya mungkin tak accurate. Right, so once you stop at the turning line, so the next checkpoint is the load transfer coefficient, which is the J value. Right, so J value is 4. So you have here 2.2, 2.3, 2.2, 2.5, 3, 3.5, 4. Okay, so 4, 4.5. So your drainage coefficient is, we picked 4 just now, your J value. So straight away go to the 4. Okay, you draw, take your ruler. Okay, 4. Okay, right. Alright, so extend slightly the turning line. Okay, mungkin turning line dia tak ni. So panjangkan sikit, you extend the turning line up. Okay, right. Oh. Okay, right, everybody, are you with me?
Yes.
Okay.
Yes.
Right, next is drainage coefficient. Right, what is the drainage coefficient? Berapa tadi?
1.12.
1.13.
Yes. 1.12.
1.1. Okay. 1.1. So roughly here, 1.1. Right? This is if you look here, the scale 0.6, 0.7, 0.9, 1.1, 1.3.
Almost 1.1.
Almost 1 point. So we nearly go to here, somewhere. Not really. Okay, just 1.1. Okay, almost 1.1. Alright. So we stop at roughly about, saya tak tahu lah, my I got about 80. What do you get? You get 80 or 79? My matching line, we stop at 80.
78.
88.
78.
78. Tak apalah. Okay.
Yes, 78 juga.
80, 79. Okay, never mind. It's okay. Alright. So use your value. Okay, don't just use your value. So the next one, once you have this, you continue to the second part. Right, the second part of the normal graph, the next page is this one. Okay. Bersambung-sambung dia, panjang. Okay, I make it bigger. Turun bawah. Oh, turun bawah. Okay. Now, so we let's say you got apa tadi? 80 right or 78. Okay, we go to 78 or 80 or any value that you stop. All right, this is 70. So somewhere here, right? You go to the loss of serviceability, which is 2, right? So we have 0.5, 1.0, 2, and 3 here. Okay, so draw from the value that you stop from the match line. Go to the 2, okay, 2. Oh Allah. Susahnya. Allahu Akbar. Allah bergerak pembaris ni. Guna pembaris betul juga senang. Tak boleh lah. Saya give up lah. Aduh. Jangan bergerak. Alah, tak apalah. Allahu Akbar teruk. Berapa awak dapat? Sekejap. Terkiat-kiat. Okay, lebih kurang lah. Oh, where is it gone? Allah Akbar. Begini. Okay, alright. Mine is not correct because my ruler is stupid. So I got something not so two lah di bawah tu. Okay. So where do you stop? Okay, just stop at this point. Okay, at this point, and then we go down. Okay, we go down. Okay, from here we know the reliability. So what's the reliability? Is 90%, right? Okay, the reliability for this design is 90%. So we start from 90. We go to the standard deviation, which is 0.35, right? So 0.2, 0.3, 0.4, 0.5, 0.6, so 0.35 somewhere here, alright? So 90% to the 0.35. Okay, 90% to 0.35. Then the next one is ESL, right? ESL W18. Okay, there are lots in chat box. What's your chatting? Oh, Fatin dah siap dah. Apa benda tu Fatin? 5.8. Okay. So W18, what's the value of W18 just now? Can you please tell me?
1.8.
1.8?
Yes.
1.8 million. Okay, so 1.8. So if you look here, all right, this is 0.05, 0.1, 0.5, 1.0, 5, 10, 50, 100, 500, and 1,000. Okay? So ours is 1.8, so somewhere here 1.823, so 1.8 here, right? 1.8, so we draw a line from where that we stop, go to the 1.8. Oh, tak accurate ni, tak accurate, salah. Sengit. Betul 1.8. Okay, 1.8 lah lebih kurang. Okay lah, tak apa. 1.8, then what else? What you have to do is, alright, you have to draw a line vertically up and this one horizontally goes here, alright? So where these two lines meet the point and read the value, this actually referring to the thickness of the concrete slab that you will get. Okay, so in my my design here, okay, mine I got about berapa inci ni? Dia dalam, okay.
8.
Okay, tak apa. I think mine is not accurate. What do you get for yours?
8.5. 8.5.
8.4. Okay, 0.4.
Yes, 8.4, 8.5.
Alright,
Yes,
good. So we have 8.5 inches. Okay, round out to the half inches, 8.5 inches of the concrete slab thickness. Okay, alright. So it will be easy if you have all the information ready. So once all the variables ready, then you can just use the normal graph. Just join the point and get to the final value of this thickness. Okay? Any question on this? No?
No.
No. Okay. All right. So then I'll give you assignment later on this. Right? We move on to the next method. Okay. The next method, which is the finish lah. We finish on this. Which is the PCA method, or we call it as Portland Segment Association method. Okay. So this method is based on mechanistic empirical. Okay, it can be used for all types of payment, JPCP, GRCP, CRCP. Okay, so and this method has the charts, the table that you will refer after this is all been developed. Okay, based on this feed-in element calculation. Okay, JSLab, the software that they calculate to produce the tables and charts. Okay. Design criteria to develop the charts. Results are from actual road tests and other studies. Okay. So, okay. Since it is a mechanistic empirical, as I said, so we need to determine two parameters. So the design has been based on fatigue failure and also the erosion failure, right? If you still remember that I did explain to you about the erosion, the subgrade erosion, the subbase erosion, right? On the concrete pavement. Okay, these are the two types of fatigue, two types of failure that the design has been developed based on these two failure. All right. So if you look on the fatigue analysis, this is where the fatigue will be very critical, okay, when, okay, the edge stress at center of the slab, okay. So the fatigue failure can happen, right, when at the critical scenario, critical condition where the load is actually in the middle of the slab and at the edge of the slab. It's actually at the middle and edge of the slab. Okay, this is when the probability fatigue failure to happen would be very high. Okay, so for the fatigue analysis, you calculate what you call the damage ratio. Okay, the damage ratio due to the fatigue failure. Okay, and Ni is the predicted. Ni is the predicted allowable load repetition. Predicted, and the big Ni here is the allowable numbers of load repetition. Okay, so the damage ratio, okay, between predicted divided by allowable need to be less than 1. Less than 1 lagi. Dia kena kurang daripada 100 atau kurang daripada 1. Cannot be more than 100, cannot be more than 1. Need to be less than 1. Okay, so for erosion analysis, okay, the critical condition is when the load is at the edge and corner, at the corner of the slab. Okay, when you have this load at this point, that is where when the erosion analysis, the probability of erosion analysis to happen going to be very, very high. Okay, so they put this the load condition at this point, so and then they calculate again, they calculate using the software and they come up with the tables that you're going to see after this. Okay, from this erosion analysis, the design has been based on this. Okay, percentage of erosion damage divided by C2. Okay, it's depending on the asphalt shoulder. It's depending on the type of the shoulder that you use, whether it's a concrete shoulder or asphalt shoulder. Right. So you use this value. They use this value. No, you don't have to use this value. They use this value if you're using asphalt shoulder and this value for concrete shoulder. The same thing, Ni is the predicted divided by allowable. Okay, allowable. And this also cannot be more than 100. It should be less than 100, less than 1. Okay, right. So now, the design factor, okay, it's quite similar to what been discussed. Okay, you need to know the modulus of rupture of your concrete mix. Then you need to know the subgrade and subbase support, the design period, and also the traffic. Traffic is the same as the ESL. Alright, the modulus of rupture. Okay, the modulus of rupture, I think it shouldn't be ada masalah. Ni sama je lah, sama. Okay. Never mind this one. The coefficient, this one. Okay. The subgrade support is depending on the normal or summer K. Okay. So again, they don't. It is different, slightly different with H2. H2 they take consideration 1 year, right? But for PCA they take the normal or the summer K. Okay. They use the same thing, the subgrade reaction based on the plate bearing test. All right. So if there's a subbase, okay, if there's no subbase, the K is depending on the subgrade. Okay, if there's a subbase, meaning like you have subgrade, subbase, so the K value will be slightly increased, depending on the subbase, depending on the how thick is your subbase that you want to apply. Let's say, okay, this is a table. If you're using this is the table for subgrade K value. If you're using this is the subbase thickness. Okay, this is your, if you're using, what is it? It doesn't. This is a normal granular subbase. Okay, unstabilized. Sorry, this is for unstabilized subbase. This is for cement treated subbase. Okay, all right. So let's say if you have a 50, the K value for the subgrade is 50, but then on top of that you have a 6 inches unstabilized subbase. So therefore, the K value that you're going to use for your design is you're going to increase slightly up to 75. Okay. Okay. For example, for this one, if you say you have a subgrade with a K value of 100, But then on top of that, you have a 4 inches cement treated subbase. So therefore, the K value that you're going to use for your design would be 280. Okay, that's how they the subbase affect the subgrade design. Okay, design period normally 20 years, and also they have this load safety factor. Okay, load safety factor depending on the volumes of road. Okay, they have 3 categories: low volume, 1. Okay, highway and arterial streets 1.1. If it's an interstate pavement 1.2. Okay, interstate pavement ni macam free, expressway lah. Okay, expressway. Ni macam jalan negeri. Okay, jalan negeri. Okay, ini untuk jalan-jalan kampung. Okay, jalan negeri, jalan persatuan 1.1. Ni macam expressway kita guna 1.2. Okay, right. So my discussion, normally I won't go through the slide. I will go through this based on this RIM handouts. Okay, guidelines to the design of plain concrete pavement. Though nama dia plain, but then the design actually can be applied for all types, GRCP, CRCP, JPCP, and so on. Okay, so I don't know whether I've already uploaded the handouts which has been actually part of this guideline. I put inside the e-learning. Did you print or you didn't print or you just save inside the computer? Do you have a hard copy?
Yes.
Oh, you print You print. This one. This one.
I haven't print.
In this one kan? You print already? Dalam 20 page lah. Kalau better for you to print lah. Right. So if you can see here, there are lots of tables, figures, and so on, right? So this has been developed using by the JSLab, and if you see here, this is based on Malaysian standards, so you can see all the values already been converted into MPa. So previously dia guna apa? Kilonewton kan? PSI, PCI, right? So all the value has been converted into Malaysia punya unit lah, unit metric. Okay, so I didn't photocopy the whole book. I just picked one section, which is actually the section which discuss on the thickness. Okay, the thickness. Okay, the thickness design. Right. So you can have a read depan depan ni. Okay, this is basically step by step that they use to calculate the traffic loading. Okay, start with the traffic loading, and then you go to the axial load distribution, and then this is where they start with the trial thickness and the analysis. Okay, you can refer to this, but I want us to go through straight away to the example. So from the example, it's actually it follows the steps earlier lah yang dia cerita dalam ni. Okay, let's give it here. If you look here, the design period for this is 20 years. Okay, and it's given to you the initial average daily traffic for both direction. All right, again, okay, this is not ISIL yet. It is average daily traffic, which is 17,000 vehicle per day. Okay, 17,000 kenderaan per day. And from this 17,000, percentage of truck, okay, the commercial vehicles is 13%. All right, as I said earlier, we only interested in commercial vehicle. For a design, you're only interested with commercial vehicle, right? It's given the growth rate, okay, is 5% and directional split is 50-50. So what they calculate first is average daily truck traffic, ADTT, average daily truck traffic, where we have the initial ADT, all right, 17,692 times the percentage of trucks or percentage of commercial vehicle, which is 13%, times 50%. 50% because this is for 2 direction. They multiply 50 because we assume 50-50, right? We assume the directional split is 50-50, right? So therefore, they get 17,692 times 13% times 50%. They will get 1,150 trucks per day. It's not 1 year yet. It's per day. Average daily truck traffic, ADTT, right? 1,150 trucks per day per direction. Okay, per day per direction. Then they project they wanted to find what would be the amount of the numbers of trucks for the next design period. All right, so they multiplied with the projection factor. Projection factor 1.6. Ini kat mana figure dia ni? Table 3. If you refer to table 3, where are you? Table 3. Table 3. Yes, projection factor. Yes, this one. It's in the guideline, page 27 there. Table 3 is given to you, okay, the yearly rate of traffic growth, 1 to 6, and the projection factor for 20 years and 40 years. So ours is, berapa persen tadi? 5% 5 ke 3? Growth rate dia?
5.
5. Mana tadi 5? 5. So 5 with 20 years, so therefore we have 1.6. Right? So it's given, that's where they come up with 1.6 here. Alright, 1.6. Right. So what happened? This is a formula that they refer in order to calculate the numbers of trucks for the next apa namanya, Allah Akbar, for the next 20 years, where the ADTT times the projection factor times the T is 20 years, and the 365 to convert it into 1 year. Okay, 1 year. So the ADTT times 365, okay, convert to year numbers of trucks per year, and then times with the projection factor and the T value, all right? And they will get the number of trucks for the next 20 years, 13 million. Okay, 13 juta truck. Right. So then after that, it is been told that this lane is actually a 4-lane dual carriageway, meaning one lane they have 2 lanes per each side, 2 lanes per direction, right? So you need to multiply with lane distribution or the design lane. Okay, so this one they refer to figure 3. They also given the specific figure 3. Yes, this one. All right, this figure, the same page, page 37. All right, it's given from here. You need to know what will be the ADT per direction. Okay, so our ADT is, what is our ADT? 17,000, right? Roughly about 17,000. Right. Our ADT is 17,000. Yeah. Ni 17,000 They are asking about ADT 17,000. But then, okay, this is Allah Akbar. Okay, this is the ADT for one direction. So your 17,000 you divide by 2. Bagi 2 because we assume that 50-50, right? Okay, so divide by 2, roughly you will get about 8,000 plus lah. 8,000 17 bagi 2 berapa? Lebih kurang lah kan? Lebih kurang 8,000 lebih, right? 17,692 just now. Okay, divided by 2. Okay, you have about 8,000 or 9,000 plus lah. Right, so you go to the value here about 8,000. All right, 8,000 plus or 9,000, and what do you get the values? 17,692 bagi 2 berapa?
8980.
Alright, somewhere here lah. Okay, roughly estimate. You draw a line, go to the 2 lane per direction because it's a 2 lane. It's not 3 lane. If it's a 3 lane, you use this line. If it's a 2 lane, you use this line. So they draw a line, reach to this point, and vertically, vertically goes down and get the value here. So the proportion of numbers of truck traveling on the design lane will be 0.81. Okay, 0.81. Okay, faham You get what I'm saying? Do you follow me or I'm talking too fast?
Faham.
Okay, alright So please tell me if you lost, alright? Alright, so that's where they multiply the VT here, okay, multiply with 0.81 and finally they get 10 million trucks traveling for the next 20 years per lane. Okay, per lane, per direction lah. Okay, for one design lane. Okay, alright. So,
Doctor?
yes, Zaid.
Okay, we divide it by 2 because the percentage is 50-50 or because it's two-way?
It's two-way and the percent 50-50.
Oh, if you have 60%, we must do another thing.
Okay, normally for directional distribution, okay, for directional distribution, we always use 50-50. For lane distribution, you can have 70-30, 50-50. Normally for directional distribution, most of the methods, most of the design method, they use 50-50, directional distribution. Or if let's say you said that you have traffic study data saying that those going to Johor Bahru is 80% and goes to KL is only 20%, then you can use that. But you need to have exact study, traffic study information lah on that. But normally, practically they use 50-50 for a directional distribution. Okay, Zaid.
Okay, Doctor. Thank you.
Okay, right. Okay, so done. We finally get the numbers of trucks. It's not ISL yet. The numbers of trucks, the design VT for the next 20 years per lane. Okay, per lane, per directions for the next 20 years. So the second step is actually to get the axle load distribution, the expected repetition. This one. Right. Okay, so how do I explain this one? Okay, this one, maybe could you turn on the first earlier page? Okay, so I already explained this one, this top, okay, this earlier that we've gone through this one. We've gone through this one, the first part, which is on the traffic volume. Okay, I already explained the traffic volume. Now we go into the second part, the B, okay, which is the axle load distribution. Okay, let's read together what they write on this. Okay, axle load distribution for data for single, tandem, and trident axle may be obtained direct from the actual weigh station data or the national axle load study. Right? So meaning you need to know, you need to conduct an axle load study, because you wanted to know the axle load distribution for different types of single and tandem. Okay, you can get it. You can get it from the either you conduct an axle load study data, or if you don't have the axle load study data, if you have the data, what you can do is this one. In the absence of the more specific data, the axle load distribution, okay, in table 15 of the PCA guide may be used to generate the expected repetition of each magnitude of axle load for single and tandem axle groups, depending on the axle load category. Okay, so the axle load category is selected from table 9 in the PCA guide based on distribution, blah, blah, blah. Right? So what I'm trying to say, this one, okay, this value is actually, you need to calculate from, you need to get it from the axle load study, right? If you don't have this information, okay, if you don't have these informations, what you can do is you can use the one that they provided in this, which is in yes, this one. Okay, table 9. Okay, table 9 and this one, table 15. Okay, so if you look here, table 15, all right, so they have, you need to know this one, the axles per 1,000 truck, okay, the axle load distribution. You need to know what category you're in, category 1, category 2, category 3 or category 4. Okay, so the informations that you want to take from this table is actually this one and also this one. Okay, let's say if you're choosing category 1, these are the things that you take from this table. Okay, how do you decide the category 1, category 2, category 3 or category 4? Okay, this one, okay, this for single and this for single and this for tandem. Okay, how you do determine the category 1, category 2, 3, 4? So this one you can be based on this table, table 9. There are 4 categories with description on it. So you have to look on these things first. Okay, what would be things that you could look at is your average daily traffic, your ADTT, okay, Okay, ADTT is the average trucks traffic. Okay. Okay, so from here you know what is it, is a residential road, collector road. Okay, this would be the high volume lah, the expressway. Okay, so depending on this, whether it's category 1, 2, 3 or 4. So if let's say you think, okay, you are going to design a category 3, so you go to this table 15. Okay, you pick the Excel loads distribution. Susahnya conteng dalam PDF ni. Dia lembab sikit. Tak apalah. Okay. So you go to this table 15, go to the category 3, you take this value and what do you call the Excel load per kilonewton for both singles and again for tandem. Okay, category 3 tandem. Okay. Okay. Right. Faham tak faham? Do you understand what I'm saying? And you take this information, you take these values, okay, go back to the one that we have here. Here. You put it here. Okay. Axle load and numbers of axles per 1,000 truck for single and also tandem. Okay. Right. Any question on this? Who don't understand?
Doktor.
Okay.
Malaysia guna ni?
Malaysia guna ni? Guna ni? This
So,
for marine.
apa nak buat kalau dia 4 lane and more? Sebab graf tu kan 2 lane dengan 3 lane.
2 lane dengan
Graf yang percentage of truck.
oh
Yang untuk dapat 0.81 tadi.
right. Okay. Normally kalau 4 lane or more, normally what they do is they use, I think they will need to conduct a traffic study lah kot. Traffic counting. Okay, traffic counting. But it is quite difficult lah. But I would say if they use 4 lane, 3 lane and above, saya rasa dia akan guna 4 lane punya proportion. Okay, if you have more than 3 lanes for couple, they will use this one. Okay, alright. Apa lagi soalan? Faham tak yang ni? This one, do you understand? How they get this information? Alright.
Yes.
Once you have this ready, okay, this single axle, tandem axle ready, so then this one you calculate from the traffic volume, right? The VT you calculate from the traffic volume. They got about 10,008,000, right? So they just round it up to 10,008,000. Allah Akbar ni apa? 10,880,000 lah. Senang cakap orang putih tak reti. Okay, so now we need to calculate the expected repetition. How they calculate the expected repetition? Macam mana Saya pun dah lupa dah. Setahun tinggal. What you have to do is you have to multiply. You have to multiply. Allah, dah tak boleh nak conteng. Kejap, saya cuba padam. Dia padam is quite slow using ni. Serabut dah. Okay, okay. Sikit lagi. Okay. Right. So, how to get the expected repetition? 0.58 the axle load per 1,000 truck multiply with the VT, right? And then divide with 1,000. This one times this one, divide 1. After that, divide with 1,000. Bahagi 1,000. You will get 6,310. Please, can you get you calculate for me? Do you get 6,310? Or maybe 6,340, something slightly different. Do you get?
Yes, doctor.
Okay. All right. So that's how they calculate the expected repetitions. Okay. Multiply axles with the VT and divide with 1,000. All right. Okay. So you calculate for each category axle load, single and tandem for both. All right. Single and tandem. All right. So once you have this, then you need to transfer this information to this. These are actually the main form that we're going to use to do the analysis design. All right. Okay. Now let's have a look first. Let's have a look. We leave that one first. Okay. Let's have a look on this form. Okay. So at the top here. Okay. You just put up all your informations given. It's a 4-lane rule section. All right. The trial thickness. Okay. Based on mechanistic empirical, is actually you have to have a trial thickness. Just go stick to one thickness. Try with one thickness, and then you have to check whether the thickness is okay or not. The thickness can be used or not. Okay, so in this example, they start with the trial thickness of 240. Okay, they want to try with a 24 millimeter concrete slab. Does it comply? Does it can be used for this road or not? Right? So it's given. Also, it's given the K value. Okay, the K value subregulation is 35 MPa per meter, and then the modulus of rupture for that particular concrete is 4.5. The load safety factor is 1.2. Okay, because I assume that it is a high volume type of road. Yes, they're going to use dowel joints, and they will not use concrete shoulder. No. Okay, concrete shoulder, no. And the design period is 20 years. Okay, so you fill up all the information, and then we come to the form here. You can see there are column 1, 2, 3, 4, 5, 6, 7, and we have single axle and also tandem axle at the bottom here. All right, so we have single axle information and tandem axle. So from where you what you have to do is you write down back your axle load and your expected repetitions that you calculated earlier here. Alright, the axle load and the expected calculation, expected repetition. So the axle load, they have 133 until 80. Okay, so they take 133. Okay, they jot down from the biggest, kilonewton, okay, to the smaller one. All right, and then multiply with the load safety factor. Okay, this axle load, you need to multiply with the load safety factor, which is 1.2. So 133 times 1.2, it become 160. 125 times 1.2, it become 150. Okay, so the load, okay, so we are expecting that the load that will be traveling is slightly higher compared to the standard one. Right, because that's why we take consideration, we take it as what we call it sebagai load safety factor. Okay, so we slightly increase the loading by multiplying with the load safety factor as we decided earlier, which is 1.2. Okay, so the expected repetition also, okay, the same thing from here. The way that you calculate is from here. Okay, I don't know actually why the value is slightly different here, but don't worry. Okay, the calculation is exactly as what you calculate here earlier here. Okay, yeah,
Why don't they take all the values for the?
From 133 from here.
Yes.
133 until okay. So I will you will see that one later. Why? You can take all because after this you don't need all because at one point you become unlimited. When it comes to column number 4 ni. But it's okay. It's okay. I will see that one later. You can list it down. List it down. Bubo, you can list it down. But then when you calculate the column number 4, you don't need. You just calculate. It will until here only. Right? Unlimited. Once you reach the unlimited, you don't have to calculate down here. Okay, it's 0 already. All right, never mind. Okay, so take all. Okay, from what the expected findings from what you have here. All right. Okay, the expected repetition and also the axle load group. Okay, so that will be column 1, column 2, column 3. How do you fill up? Right, for both single and also tandem. Okay, tandem also you had the tandem results right here. So for both single and tandem. Okay, for both single and tandem. Okay, done. So now the calculation, the analysis will be here. Okay, column 4 and 5 is for the fatigue analysis. Column 6 and 7 is for erosion analysis. Right, as I mentioned earlier, the design, they will look on the fatigue and also the erosion aspect. Okay, how the pavement will fail. Will the pavement fail in terms of fatigue, or will the pavement fail in terms of erosion, or the pavement will not fail for both? Okay, right. So before we start the calculation for fatigue analysis, what you need to know, you need to find this one, value 8 and 9, which is the equivalent stress and also the stress ratio factor. 8, 9, and also this one, 8, 9. 8, 9 is for single, and 11, 12 is for tandem. Right. Okay. So where does this equivalent stress comes from? So that's where those tables yang bawah ni banyak. So where we need to refer to this. We need to find the table. We have fatigue analysis, equivalent stress and yeah. Okay. This is table 6 is equivalent stress with no concrete shoulder. Alright. So we have another more table equivalent stress. This one is equivalent stress for concrete shoulder. So you have to find the right table lah. In this example, they're using no concrete shoulder, right? So we're gonna refer to this table. Okay, right? Okay. So if you look here on this table, they have the slab thickness, your trial slab thickness, and the K value. Alright. So the trial slab thickness in this design, they start with 2. Allah, kenapa lah bling bling ni? PDF dah pening. PDF ni dia tak boleh conteng banyak. Okay. In this design, they start with the trial thickness of 2 for O, right? And then what will be the K?
35.
55. Right, 55.
35.
55, eh?
35.
Oh, sorry, 35. Okay, 35. Okay, 35. Okay, so it's given here. If you look here, we have 20, we have 40. Alright. So if you look in this table, alright, for 20 they have 1.58 and then slash 1.55. What does it mean? 1.58 is for single. This is for single, and the below one is for tandem. Okay, tandem value. Okay, so let's say we look on the single first. Okay, let's have a look on the single first. So we want to know what will be the equivalent stress value for 35. We have 20. 20 is Allahu Akbar. Kenapa dia bling-bling ni? 1.58. Alright. And then we have the next one is 40, right? 40 for single we have 1.39. Okay. Alright. Okay. Dah, kenapalah dia bling-bling. Okay. Alright. Let's have the given dia few minutes rest untuk PDF. Okay. Down. Stable. So now, what will be the value of 35? 20, 1.58. 40, 1.39. How about 35? Okay. So you need to do interpolation. Please do interpolation. Boleh buat interpolation tak? Pandai tak buat interpolation? Okay, because we know the value for 20 is 1.58, 40 is 1.39. So what if the value is 35? Okay, Zul Hakim, can you do how do you do interpolations? What was the value that you get if you visit 35? Okay, supposedly you will get this value. You will get the equivalent stress of 1.44. Okay. Right. Dapat tak 1.44? If you do interpolation. Senyap je. Hello.
Yes,
Doktor.
144.
Macam mana? Dapat 1.44?
Yes, 1.437.
Okay, alright. So, try and do interpolation and you will get the 1.44. So, siapa yang tak pandai interpolation tu tengok balik macam mana nak buat interpolation Alright. So, calculate. It is just a mathematic issues. Okay. Try to find the 35. What will be the value you should get? 1.44. So, you write down 1.44 equivalent stress. This is for single, for single. So, same procedure for tandem. So, if is it for tandem, you go and look for the tandem value. Okay. So tandem, we are using this value, right? 1.55 and also 1.28. Okay, 1.55 is for 20 and 1.28 is for 40. So what will be 35? If let's say if it's 35 MPa per M, so what will be the value? Okay. Alright. Alright. So you should get, again, you do interpolation and you should get roughly around the value here, right? Then you should get 1.35. Okay, so that's how you determine the equivalent stress. Once you determine the equivalent stress, then you need to know one more thing is stress ratio factor, number 9 and number 12. The stress ratio factor. Okay, so the stress ratio factor is actually the ratio between MR. Okay, MR divided by the equivalent stress for that particular value. Okay, so in this case, our MR value, which is modulus of rupture, which is 4.5 divided by 1.44. Dapat tak? Ke terbalik? Please calculate for me. 4.5 divided by 1.44 or the other way around. 1.44 divide with 4.5. I think the other way around good.
Other way around.
The other way around, sorry. Okay, wrong formula I give to you. It's the other way around. Logically lah kan, okay. The other way around, which is, okay, the stress ratio factor is the ratio between the equivalent stress divide with your modulus of rupture. Okay, 1.44 divide with your modulus of rupture, MR, which is 4.5. Okay, you will get 0.32, and also for standard also the same. Okay, 1.35 divide with your MR. Okay, you get 0.3 for your stress ratio factor. Right. So once you have your equivalent stress and your stress ratio factor, then you can proceed with this one. To proceed with this one, you wanted to find the allowable repetition for fatigue. Okay. Right. So this is where you need to go and find which figure. So this is for erosion analysis. No, bukan. Okay, kita nak tengok, kita buat fatigue analysis. So I don't know why the RIM, I already photocopy, I take it directly from the RIM, and they have like, I don't know, they also pening kot kan ya. The page also gone miss, they mix together all the figures and so on. Semua bercampur. So kena cari. This is equivalent stress. Kita nak tengok. No, equivalent stress. Oh, okay, system. Fatigue analysis. Okay, so this is actually fatigue analysis. Load repetition, blah 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 blah, without concrete shoulder, right? Okay. Right. So this is without concrete shoulder because we have more. This erosion. We have. I think we do have finished already. Satu je. Kena ada. Erosion analysis, erosion factor, fatigue analysis, equivalent stress, axial load. Kat mana satu lagi? Erosion factor. This one also. Factors no, erosion factor juga. Tak ada lah. Ada. I think there are two figures for fatigue analysis. Erosion. This is no. This is equivalent stress. This is equivalent stress. Fatigue analysis tadi figure 5. Mana lagi? Erosion factor, erosion analysis. Tak complete ke saya fotokopi ni? Erosion factor. Fatigue analysis. Allahu Akbar. Kenapa aku tak nampak? Okay, so there actually one. Okay, because it is with and without concrete shoulder. So if it's with concrete also, you're using the same figure. Sorry, saya tak nampak. Okay, so the same figure, right? With or without also using the same figure. So what you can look here, okay, on this figure, right? So it's actually on the left side here is for single and the right side here is for tandem. Okay, this is for single. This is for tandem. So let's take the first value here. The first value here is apa nama? The first value on the single axial. Ya Allah, ya Tuhanku, pergi patah balik atas pula. Okay, right? We have 160, right? The first value here for single is 160 with equivalent stress 1.44 and stress ratio factor 0.32. Okay, so go back to your figure 5 just now. Okay, so you need to draw a line also. It's given to you, it's already drawn for you. 160, you go to the stress ratio factor, which is 0.32, okay, and draw a line, extend the line up to the right side and read the value here. So this is the allowable load repetition. In this case, you will get roughly about, this is 10,020 dalam 20,000 above lah, right? 20,000. So they wrote here is as 21,000. Okay, 21,000. Okay, so try and have a look on 150. Try on your graph on your paper 150 with the stress equivalent stress with a stress ratio factor of 0.32. Okay, the same stress ratio factor, the same point. So at the same point here, so 150, right? Connect, draw a line to 0.32, extend and read the value here. Okay, dapat tak? You should get berapa? You should get 55,000 roughly. Okay, 57,000, estimated 50,000. Try and do. Boleh tak? Can you do it? I mean, can you get the value?
I got 60,000.
60,000. 150 tu? 150.
Yes.
Okay, 60,000. The rest? That's, as I said, it depends on the ruler, how sharp is your pencil, the angle. It's quite difficult. The rest, Fatin, Amira, Hazira, what do you get?
Doctor, single axle with 80.
Axle?
Single axle with 80.
Single axle with 80.
Yeah, I think it will extend it above the figure.
Which one?
80.
80.
Yeah.
Which wait, 80. Ni kalau begini 80 pula tiba-tiba ni. 80? Where? This one. This one.
Yes.
Okay. Don't use this one. Okay. Use the after being multiplied with the load safety factor. Okay. Right. I was just asking you at this point, Zaid. You're so fast. You're already doing this level. Okay. Never mind. I'm asking you. Do you manage to get 55,000 here for this 150? Do you get 55,000?
Yes, doctor. But
Okay,
I choose randomly.
55, maybe roughly. It should be not so. If it's 60 also can, as long as you don't go like 100. That is too much. As I said, it depends on the parallax error, or maybe the ruler, or the pencils. All right. So let's now have a look on 118. 118. So the same procedure, okay, go for 138, 128, okay, you will get this 200,000 and 900,000. Okay, let's have a try. Okay, before you go to 96 here, let's have a try first with 118. What do you get? How do you find the graph? Right? So go to 118. Okay, 118 for single. Okay, 118 for single. 118 should be somewhere here, right? Somewhere here, 118. Draw a line to 1.32 and extend. Try to get what would be the value that you get. Do you get any value, or you didn't get? The line goes outside the scale?
Outside.
Yes, right. That's where
2 million.
all right. So it goes beyond the scale. So once it goes beyond the scale, keluar pada scale dia tu. So that's where you put, yes, you stop. You put it here unlimited. Unlimited. The same goes to if at one point you define at one point you have found unlimited, definitely the rest, the smaller value goes down here, you will find unlimited as well. Okay, that's why you stop calculating the apa nama, the allowable repetition. Okay, so until within the scale only. If it goes out the scale, that's where you stop. You don't have to calculate more. Okay, right? So you calculate for both, for single and also for tandem by using the same figure, right? So if is it for tandem, you use the left side. Okay, the left side scale here. Yeah, this for tandem. Okay, the left side, the right side. Okay, the right side. This for tandem. Okay, if is it for single, you use this one, right? Fine, to get the allowable repetition. So once it goes beyond outside the scale, so that's where you say that the value has gone to unlimited. So that's where you stop. Okay, so for tandem, they stop at here. They stop at 256. They stop at 256. Because at 234 also has gone to unlimited. Okay. All right. Any questions so far? For column number 4, how to calculate column number 4 here? No, right? No?
No question.
All right. So then we wanted to calculate the damage of the fatigue percent, column number 5, right? So as you remember, damage of fatigue percent is predicted divided by allowable. So the predicted value, which is which one? This one. The predicted is the expected one. The predicted or expected is the same meaning, right? Column number 3, 6340 divided with the predicted divided with the allowable repetition. Divided with 21,000 times 100%. So you will get roughly about 30%. Okay, betul
Betul lagi sekali, Doktor.
Okay. So for the fatigue percent, is actually the ratio of predicted or expected, column number 3 divide with column number 4, which is the allowable repetition. Alright, for example, in the first value here, 6340 divide by 21,000 times 100%. You will get the damage due to the fatigue failure, the fatigue percent failure. Okay? Alright. Do you get? You get?
Yes.
Okay. Alright. So column number 5 is 3 over 5. 3 over 4. Sorry, 3 over 4 times 100. Okay, you get the fatigue percent. So at this is actually the damage percent occur. Okay, when we have this certain value of load. Okay, traveling on this road. Okay, so what you have to do, you have to total up. Okay, same thing lah, same thing untuk for tandem. Okay, the expected 21,000 divided by 900,000, you get the damage percent. At the end, you have to total up the fatigue failure, the damage percent for the fatigue failure, total up from bottom for both tandem and single, for single and tandem, and you'll get 81.9. Tambahkanlah semua total up, 30 plus 26.7 plus 15 plus 7.1 plus 2.4 plus 0.7, and end up you'll get about 81.9%. So the damage due to fatigue is actually about 81.9%. Okay? Alright. So far no questions for fatigue analysis? Alright?
No.
Okay, so then we move on to the next one, which is the erosion. Okay, erosion analysis. Erosion analysis. All right, so the thing that you need to before we calculate the allowable repetition, we need to determine the erosion factor. Okay, erosion factor for single and also tandem. So where does this single and tandems come from? Okay, the erosion factor. Okay, here there are tables 8A, okay, erosion factor, dowel joints, concrete shoulder. All right, so this is not us, okay, because ours is no concrete shoulder, right? All right, so this one is erosion factor, aggregate interlock, okay, with the concrete shoulder. Also no, okay, because we are not using concrete shoulder, okay. So not this one. So we have to find the tables that tengok dia punya berterabur erosion factor sana kat sini. Mana lagi erosion factor? Erosion factor page, okay, this one. Erosion factor, double joints, no concrete shoulder. That sounds us like kita ada, we do have double joints, right? We do have double joints.
Yes.
Yes, right. Because it says here, double joints. Yes, double joint. Yes, right. So that is our table that we need to refer. Okay. Bukan. Mana tadi? Page berapa tadi? Nah ni, right? Alright. Erosion factor, double joints, no concrete shoulder. So by using the same methods as you use for what was just now fatigue stress the equivalent stress just now, right? It's the same style, okay, the same method. You go to the trial thickness that we pick, which is 240. Then we need to do interpolation to get the 35 because we have 20 and 40 here. This is for single and this is for tandem. Okay? So you do interpolation in order to get the 35. Okay, the value of erosion factor at 35 MPa per meter sub-base K. Okay, so interpolation, if you try and do, you will get, okay, later you can just try. Okay, you're supposed to get this one lah. Okay, you will get 2.61 for single and 2.8 for tandem. Okay. Alright, so far no problem for this erosion factor?
Alright, no
Okay.
problem.
Right, so then we go to column number 6. Once you have the erosion factor, column number 6, allowable repetitions for erosion analysis. So let's have a look. Okay, this one, erosion analysis, allowable load repetition based on erosion with concrete shoulder. No, this is not ours because ours is without concrete shoulder, right? Mana lagi? Erosion. This is fatigue. No. Okay. This is okay. Erosion analysis. Okay, without conclusion. So this is ours. Okay. So using the same way as I teach you earlier for fatigue analysis. Okay. You go to this for single, this is for tandem. Let's say our single, the first one is 160, right? 160 kilonewton for the single axle. And then the erosion factor is 2.61, right? 2.61 somewhere here, right? So you draw a line, okay, straight 2.61, straight, and go to the allowable load repetition and read the value here. Okay. Alright. So you should get roughly for the first one, okay, for the first value for 160, okay, you will get 1,400,000 allowable repetition. Okay, dapat tak?
Yes.
Okay, so try and do for all lah. Okay, the same way until if you goes beyond the scale, you will be unlimited. Okay, it will be unlimited. All right, it will be unlimited and just stop. All right. So then once you fill up this allowable repetition, you go to column number 7 pula, you calculate the damage percent due to the erosion. So the same way, the expected repetition, column 3, divide by the allowable repetitions for erosion, which is column 6 times 100%. Okay, so 3 divided by 6 times 100. For column number 7, you will get the damage percent due to the erosion. Okay? Any question until now? No. Okay? All right. Okay. I give you time for you to try and do or whatever you want to do now. If any questions?
No question.
Okay. All right. So I proceed. Okay. So done with that, you calculate all the damage percent for all the values here and you total up. Okay, total up, and they found out that the total damage due to the erosions for this particular pavement is 38.2%. Okay, you total up. So then what you can do from this? So what does it mean by this 81.9 and 38.2? Okay. Is it okay? Okay. Is it the 240 millimeter thickness of slab? Is it okay or not? Right. So this is how you interpret the result. Okay. both values, as I said, for both values, damage percent due to fatigue and damage percent due to erosion need to be less than 100. Okay, if it's less than 100, then you would say that the thickness is sufficient enough to cater with this problem. If to cater the load, if let's say one of it, either fatigue or either erosion, one of the value, the total value goes more than 100, for example, 105, 120, one of it, meaning the thickness of the slab is not enough, okay? It will fail in terms of, if let's say you have erosion okay, if let's say your erosion you had your fatigue you had 90 and your erosion you had 110, right? So meaning the pavement is not enough, the thickness of the pavement is not enough, it will fail in terms of erosion, because erosion it gives you more than 100% value. Okay, it will fail in terms of the erosion due to the erosion problem. Okay, so if one of the value is not meet the requirement less than 100%, so it consider that the pavement thickness is not enough. So you need to increase the thickness and recheck back recalculate back the analysis. Right? Okay. If let's say one value, let's say fatigue you get 20, and then we have erosion you get about 60. Right, 20 and 60 is actually the best way. If you have this kind of thickness, I would say the thickness is sufficient, okay, because it is less than 100. Okay, all the damage is less than 100. But then, since the damage is too low, it means the thickness is not economical. It's too thick. All right. So what you can do, try to reduce slightly the thickness and recheck back, recalculate back. So the best economical and safe thickness actually when you find both of the value close to 100. You get 80 or 70, meaning it is economical and safe. All right. If it's too low, if the damage is too low, it is not economical. Maybe it's too thick. Right. So what you need to do is you could reduce the thickness and then recalculate back and recheck back the values, the damage. Whew. Right. Any questions? Do you understand how to actually interpret the result here? Faham tak?
Yes, faham.
Okay. All right. Zaid, where are you? Do you understand?
Yes, doctor, thank you.
All right. Siwan, do you get it? Right. Zaid, Siwan, and then Yuzwan. Okay, everything's okay?
Yes, doctor.
All right. So if you have questions, okay, please let me know if you don't understand. Okay. Right. I think I'll stop until here. Right. Okay. I think I will go through one more class. Okay, one more class in order for me to go through the steel design. Okay. All right. I will give you assignment for this. Okay, for both H2 and also PCA method. Okay, you already received it. I already uploaded the Asphalt Institute. Please try and do. I don't know when is the deadline. I can't remember. When is the deadline for this assignment? Is it this week or next week?
Assignment yang baru upload ke doktor?
Asphalt Institute. Bila saya suruh?
Next week.
Next week. Okay. So I'll add more assignment. Alright, after this for PCA and also H2 concrete. Alright. Do you have any questions? Any questions for anything lah? It doesn't have to be concrete, on anything, on the flexible or on the assignment or anything. No? Yes?
No.
No. Alright.
Okay.
Alright. So far, I think that's all for today.
Okay, doctor.
Alright. Have a nice weekend, guys. Thank you very much.
Thank you.
Thank you, doctor.
Bye. Assalamualaikum.
Okay, doctor.